Hey, everybody, welcome to the Green Cover Podcast, where we have really interesting conversations with some of the top farmers and experts in the regenerative ag movement. Join us as we learn together how we can regenerate, steward, and share God's creation for future generations. One of the biggest things that people talk about right now in regenerative agriculture is biologicals and how do we get more biology into the soil and, into our crops, because we know that there's a huge amount of power in harnessing the power of biology for growing our crops and our livestock. And so I'm really excited in today's episode. We're going to talk to one of the true pioneers of the biological movement. I want to welcome my friend David Olson with Sustainable Growing Solutions out of Clarksburg, California. David has been kind of a partner with Green Cover and Elevate Ag. We'll talk a little bit about that as we are moving into putting biologicals not only on the cover crop seed that we sell, but also providing that as other seed treatments and other foliar applications. So, David, welcome to the Green Cover Podcast.
Hi, Keith. Thanks very much for having me.
Yeah, absolutely. So, for our audience who's listening, go ahead and give just a little bit of your background, how you started Sustainable Growing Solutions, a little bit of the family history, because I know your father was very much involved in this business as well. So, just tell us a little bit about how you got to where you're at now.
Sure. Yeah. So my company is Sustainable Growing Solutions. We manufacture a series of microbe inoculants for different crop objectives, as well as microbe food products and some specialty fertilizers that complement the biology. I'm a sixth generation farmer out here in California. Our family farm is 175 years old this year. So grew up on the family farm doing all the different jobs you can do. At the age, I probably starting about age 12 or so, my dad started working with organic inputs. So, of course, being 12 to 15 years old, I was the one who did all the inputs and measurements and all the trials out in
The
the
grunt
field.
work.
Yeah, yeah, exactly. Yeah, just counting, counting the flowers or counting the fruit or weighing the fruit out. Or so, really, really hands-on, great experience. So we started working with those organics, okay, 45 years ago. And one of the things we learned pretty quick was that these things were really, really useful, although typically they worked better in combination than they did when they were just by themselves. And that's a lesson that we learned that kind of comes back in a very prominent way for us later on. So then my dad actually was one of the people that helped fund and conduct the first work in integrated pest management. They actually hired a researcher away from UC Davis for several years, cooperative with several other growers, and they were doing some work trying to figure out why in our pest control program we kept having to spray more and more and yet got less and less control. So they actually did, it wasn't called IPM for several years after they finished what they were doing, but it literally was the first work in IPM. And not too long after that, my dad started working with some biological products. It was actually a spin-off product by a scientist that worked for NASA. So we used that for a little while, learned a few things. A few years after that, my dad developed his first biological
And
product.
would this have been like in the 70s or 80s? What kind of time frame there?
Yeah, that would have been about the early 80s.
Okay,
Yeah.
yeah.
So really, really a long ways back. And what he did was he just looked at, various microbes and what the functions were. And so he selected about a dozen different species that were really high functioning ones. And so that was our first product for pretty close to a decade. We worked with that and we learned a tremendous amount from, there's several products out in the marketplace that actually look a lot like his first product um, still. And what we learned was sometimes we'd put it on a spectacular result. And other times, I mean, literally on the other side of the fence line, nothing, just didn't. It took us quite a while to just unravel as like, why does it work so well sometimes and others? And of course, being farmers, we're pragmatists. I mean, a product has to work every time you use it, not just some of the time. It just has to have a reliable outcome and a reliable return on investment. And after we really started working with a lot of different growers and looking closely at their production soils, what we realized was, a healthy soil should have, 1,000 different species, or 600 to 1,000, and up to 1 billion microbes per just, milliliter. And as we looked at these production soils, we realized just how profoundly they were impaired as an ecosystem, because the soil biology functions on all these interdependencies in relationships, and that's how a soil is healthy and resilient, is it has all these complementary functions and overlap and ability to adapt. Well, when you have a really depleted biology, bad things start to happen, right? You get these runaway diseases. But the other thing is if you take a product that only has a few species and try to inoculate a soil, first, the few species can't possibly fix the fundamental problem of that lack of diversity of population and function. But also because some species are good early colonizers, like some bacteria, um, they can actually land in an impaired soil and typically colonize reasonably well. But there are other species that are really important to a high functioning and resilient soil, healthy soil and plants. Don't colonize until you actually have a more complete set of biology in the soil. So what we were seeing with our first product with the selected high functioning species is sometimes they'd land and they'd have, a cohort of resident microbes that they could work with, and they would colonize and they'd wake up and do their jobs. Other times they'd land and they just didn't have anybody to work with, and they'd fail to colonize, therefore fail to perform. So once we realized that that was the kind of core issue that we're trying to address, we realized that our true mission was to restore all of the biology and all of the beneficial functions in the soil, not just a handful. And in order to do that, we really need to have maximum biological diversity. So for any beneficial function, and we can list them all off, and they're myriad, because plants and microbes co-evolved and they're in amazingly intricate set of interdependencies. So we wanted to have not just one or two microbes that do each one of those functions, but literally dozens. So that's what led us to kind of our philosophy of how we approach biological products. And our current product lines are now products that are have thousands of different species and populations that are extremely high compared to most biological. So we have populations of 1 times 10 to the 10th to 1 times 10 to the 12th. So if you're into exponents, that means 10 billion microbes per milliliter up to 1 trillion microbes per milliliter. And that makes it, so if you compare that to, say, a product that has 1 times 10 to the 7th, which is fairly common for a lot of biologicals, that means we have 10,000 times more microbes than a competitor product. And it is kind of a numbers game when you're trying to get
And like you mentioned
biology.
earlier, it's not just the quantity, but you've got this across thousands of different biological species as well.
Yeah, and that's another important thing that we learned was about microbe fitness. So microbes, a lot of them, if you look them up, and we could even talk about how you can look them up and become a little bit more educated about what microbes can do, which functions. Most microbes can do more than one thing, and that has to do whether or not they've activated a gene sequence. So that's called epigenetic activation. So if you buy, a product that was microbes that are just grown in a lab, you grow as many microbes as fast as you can, and that's all you do. So those microbes technically have the genetic potential to do the beneficial function that you want them to do, but they're not actively doing it because they've never done it in the lab. So when that microbe that's from a lab culture lands on the ground, it has to actually find the conditions that kind of encourage it to switch its metabolism to turn on those gene sequences to do that function. So you buy a product that say it's supposed to do nitrogen fixing. It's like, well, those microbes might or might not choose to do nitrogen fixing. If there's if it's a tight soil and there's very little low gas exchange, so there's no air for them to fix nitrogen out of, like, well, they probably won't do it because there's not much nitrogen available, or if they do, they're not going to do it very well. If there's low carbon in your soil compared to the amount of nitrogen, and I'll tell you that that's most production soils, the microbes won't decide to fix nitrogen. They could, but there's no real benefit to them and the rest of the population of the microbes because life works on a ratio between carbon and nitrogen. So you have anywhere from 15 to 20 carbon for every nitrogen. That's what their tissues are made out of. So if you have more carbon than you do nitrogen, then a microbe that has the ability to fix nitrogen is really motivated to do it because it's a limiting factor, not only to its growth and reproduction, but also the rest of the community. And they will even support those microbes because it benefits them all. So um, the big difference with our biology is that we grow the entire community together. So all of those thousands of species are actually grown together at once. And we actually put them in a condition where they're forced to do the beneficial functions that we want. So they're not only capable of doing nitrogen fixing, but they've been forced to do it. So we've turned on that gene sequence so that when that microbe that has the capability of fixing nitrogen lands, it's already metabolically dedicated to that function. So we don't have to guess as to whether it's going to do it, it's already doing it. And that goes for phosphorus solubilizing, potassium solubilizing, all the cytophore functions, which is the chelation of all the cations. We force the microbes to do that. So that's a big differentiator in our approach compared to a lot of other products.
So maybe to use a bit of a sports analogy, you are recruiting athletes with your kind of your raw microbes, and then you're putting different groups of them through different types of training and teaching them skills so that they can play different positions. But then when you send that out to the field, you're sending out the whole team and not just a bunch of quarterbacks or a bunch of defensive players. You're sending the whole team out because you've trained different groups to do different functions. Is that somewhat correct?
Yeah, right. It is training them. It's directing them to do the job that you want them to do. So we call it directed biology here. So we're very cognizant of training them to do their job. But you also bring up another point, which is some really important beneficial functions that microbes do for soil condition and for the plants are actually not individual jobs. They're actually, I would call them team sports. So as an example, something like crop residue decomposition. So it's not just one transaction, it's actually a series of transactions. So it's not just one microbes, it's a series of interdependent microbes. So if you have, say, a decomposer inoculant and it's only got a handful of species, it's like, well, I'm going to guess you probably have selected microbes that can produce like cellulase enzymes so that they can break down cellulose. If it's a bacterial product, that's probably mostly what you're getting. Um, but there's a dozen other enzymes that are involved for other tissues. So if you just stop at that one, you've really got very incomplete decomposition. Then when you get to other tissues like lignins, they're much harder to break down. And bacteria can produce lignase, but by far it's the fungi that do the heavy lifting on breaking down the lignase. So uh, yeah, so when we give that kind of team analogy, that's a really important one. It's like, nope, can't be just a handful of ones that do the one job. It's got to be a whole collaboration, a whole cohort of a consortium of microbes that fulfill that function.
Yeah. And and really that was one of the things that really, drew us to your products initially was your emphasis on diversity because that matches up so well to, what we do at Green Cover, trying to provide as diverse of, plants and plant families from the seed standpoint, but then being able to add a super diverse biologically rich inoculant, seed treatment inoculant on top of it, just really made sense. And then the other part was, we know that almost all of our soils are really lacking in the fungal component, and many of your products are really rich in the fungal component compared to a lot of other products out there. How are you achieving that? Because the fungal is much more difficult to provide than the bacteria, is my understanding. How have you kind of overcome that and have these fungally rich products?
Sure. Well, I guess a lot of it has to do with how you source your biology. So we collect cultures literally from biomes all over the world, over 20 different ones so far. Virgin habitats that have intact biomes, and so we'll collect cultures from that. So it goes literally all the way from the Arctic Circle to tropical rainforest and alpine meadow. So we've collected all this biology. So one is starting out with a good source of biology. Two is knowing what food rations and conditions can propagate those fungi. So we've learned quite a bit about that. And then the final one is actually process. So we produce our biology through a series of production steps. There's about 5 different steps. Actually, it takes about 6 months over the entire process. The active production process is just a couple weeks, but the pre-process is quite lengthy, and it's critical to developing not only that diversity, but also forcing them to adopt those functions that we talked about. So, and also that's critical for us getting the population sizes that we do. And I should mention that another thing that really differentiates our products, especially compared to say lab cultured stuff, is that our product incorporates a tremendous amount of metabolites from the microbe community because we're growing them with food over a protracted period of time. So they have the ability to build up a reservoir of all these secondary metabolites that are bioactive compounds on the plant, as well as the rest of the environment. So that includes in some of our products very specific sets of enzymes. So we're talking about the Decomposer product. There's lignase and cellulase and several other enzymes like built up in that. In the case of the enzymes, and there's also plant growth regulators and things that are also secondary metabolites that also directly act on the plant. To give you an idea as how many of those there are, there's 7,000 different compounds that are microbe metabolites that are antioxidant. So it helps as, say, anti-stressor processes in a plant, helps with all sorts of physiological efficiency and different processes of the plant. And then there's 23,000 other metabolites that are directly bioactive on the plant. So, I mean, we're talking about this really complex soup of things that really do optimize the function of the plant. Our advantage is those are built up in our product. And so when you apply it, you see a response immediately. Other biological products, those microbes will produce those metabolites over time. Just the response is much slower because they have to do it kind of in situ. So
Yeah.
that's a big advantage
So,
for
so
us.
you're not only getting thousands of species of biology, you're getting tens of thousands of those metabolites or those signaling molecules. And I know, we've heard Christine Jones say that, sometimes those metabolites or those signaling molecules are just as important, if not more important than the actual biology to the plant, especially
Mhm.
right at first, because, the plant sees those signaling molecules and you kind of indicate that there's biology there and biology coming, and that, triggers some of that quorum sensing that really gets the plant functions going. Is that correct?
Yeah, actually, that's part of the elegance of the relationship of the biology and the plant. As I mentioned, they co-evolved. So these relationships are just really intricate and profound, and actually just really inspiring because If you think about all the physiological processes that a plant goes through when it's got cell initiations, cell division, cell differentiation, cell elongation, so we've got all these, fundamental processes. Well, those are all triggered by different plant growth regulators. But in every one of those processes, there's an initiating hormone and then there's a regulating hormone. So always at least two are involved. So if a plant's deficient in any of those, and it does produce its own enzymes, but the microbes produce a very complementary and augmenting set of plant growth regulators, you see these physiological processes go much, much more efficiently. So when a plant shifts between a vegetative growth stage and a reproductive growth stage, and of course, in many of our plants, they switch back and forth several times during their growth season. Um, you have to appreciate how many profound physiological changes are going on in that plant. It's growing different tissues, different structures, and it requires different nutrients in different ratios. They're being translocated to different parts of the plant. There's different acids and starches and proteins that are being developed and put into those materials. So, and then of course, nutrient translocation. So there's all those things that the biology helps make the plant more efficient. So when it goes through those processes, it's really physiologically dedicated to building a high quality structures and being really healthy and efficient in its processes. That's how we get, photosynthetic efficiency so high that we see, all these monstrous numbers in brick. It's like, well, instead of looking at a plant that's like 4 or 5 bricks, we're looking at one that has 10 or 12. Well, you get the efficiency of your photosynthesis up to that 10 or 12 range. All of a sudden, you're pretty bulletproof to almost any pest and disease. And so farming gets to be fun again. And you're kind of letting the biology do the work for you. And actually that's, seeing as we kind of went down this track, talking about the relationships between the microbes and the plant and everything that they do. So we just talked about these metabolites and what they do for the plant, but let's talk about what the plant actually does for the biology. So we just talked about how we make the photosynthetic process more efficient. Well, what that allows the plant to do is produce more photosynthate, that is sugars, than what it uses for its own processes. So it takes those excess sugars and translocates those down out through the roots as exudates. So it's using those exudates to actually feed the microbes that are directly in that rhizosphere. So now it's building that population. And so that's beneficial, right? Because now the plant has more biology working for it. But embedded in that food is also signals. So the plant's saying, hey, what I need from this community right now is I'm going to do this function. I'm going to need more phosphorus or more potassium or more manganese or whatever might be its limiting factor for what its peak demand is that's occurring then. So if you think about it, it's really elegant. If we can reestablish this biology and this relationship and that virtuous cycle, that function, that cooperation between the plant and the biology, we're letting the plant now dictate its own fertility. We don't have to dictate to it. As farmers, we're trying to nurture our crop, trying to put on what it needs when it needs it. But we're pretty imperfect in our execution,
Yes.
as hard as we try. And of course, there's many subtleties, and it's fast moving because there'll be a window of time where manganese is super, super important. It's whether or not it's going to split a zygote and have, 2 fruit instead of 1. That's a pivotal moment in the physiology of the plant and the potential yield of the crop. But 2 weeks after that window, manganese is not that important. So just as using it as an illustration, but if the plant gets to dictate that, and we've made sure that the biology is there and functioning and has all the building blocks that it needs to deliver to the plant, you start seeing a plant that reaches levels of health and function that we don't ordinarily see. And then that's when things get fun because all the pest and disease problems go away.
Yeah.
And I refer to this as the virtuous cycle because a healthy plant has more exudates to feed the biology. The biology gets bigger and more efficient, and so therefore it does even a better job of feeding the plant. So the plant gets even healthier and gives more to the microbes. So you have this virtuous cycle that's self-reinforcing, and it's just a beautiful thing when we can get there. That's actually when we do our crop programs, we're not only restoring the soil biology, but we're also doing foliar applications and utilizing these metabolites. That foliar application, which we oftentimes are combining with some targeted nutrients for a particular crop growth stages, is designed to kickstart that virtuous cycle because those metabolites, even in in a only marginally healthy plant, will elevate its photosynthetic efficiency for a short period of time. During that time, it's going to push its first set of exudates. Well, that's kickstarting that virtuous cycle. And so that's one of the reasons why we integrate foliar applications so often in our integrated biology and fertility programs.
And you mentioned that that makes farming fun again, but it also makes it profitable, which makes it even funner.
Yeah, profitability is a cornerstone to fun.
Yeah. Yeah. So when we can take advantage of all those natural functions and let the system work the way that, God created it to, yeah, it's a beautiful thing. I want to get back, David. You mentioned the manufacturing process, yeah,
Mhm.
of how that's a 6 month process, from beginning to end, but the actual, that final process is a couple of weeks. I want to just be very transparent with our listeners here. So Green Cover owns a portion of a company called Elevate Ag, based out of Kansas. We own that with some other Kansas farmers. And Elevate Ag is a distributor and a manufacturer of biological products, mostly using a lot of your ingredients, David. And just recently, we're forming a partnership with you, a joint venture. So Elevate Ag and Sustainable Growing Solutions is forming a joint venture to where we're going to be manufacturing your products right here in Nebraska. So we're at Green Cover here. We're putting up a brand new building. We were starting to hire new staff, and so that joint venture between Elevate Ag and Sustainable Growing Solutions. The result of that is going to be we're going to be able to make these products that you're talking about. You're going to be providing the raw ingredients and all of the technology to help us do it, just like what you're doing in California, but we'll be able to make those here in Nebraska. So we'll have better access, we'll have less freight, and really good access to these high quality products. So just wanted to explore that a little bit and talk about this new joint venture. We're calling it Ark Biome. Kind of the Noah's Ark and the biome of just all of these living creatures that are going to go out and repopulate our soils. Uh, we're very excited about it, and I know you are too. And how do you see that being a benefit to, because you located in California, you're getting a lot of your products to the specialty crop California markets. How do you see this being a good way to extend your reach on this biology to, the broadacre crops out here in the plains in the Midwest?
Sure. Well, of course, we've been working together with Elevate Ag as one of our distributors in the Midwest for, I guess, probably at least 5 years now, I think. And there's there's so many reasons why we're doing this. Um, One, it's been a super effective partnership. We can produce great products, but you have to know how to use them, and especially how to integrate it within the cultural practices and economics of the crops you're working with. So we're currently working with over 70 different crops and in 25 different states. So we have a lot of experience, but you have to have the people on the ground that have the day-to-day working relationship with the grower. That's just necessary for having the correct depth of knowledge about how to use the products, how to help the growers be successful, walking them through the process, helping them, measure success. So, I mean, that's why our relationship with Elevate has gone so well, is because they have actually a very education-oriented approach to how they support their growers, and that's our philosophy. And so that was the first thing that I think bound us together, with the philosophy of creating a quality product, but making sure that it's applied that works for the grower. And so we really have an integration kind of approach and an education approach for our growers. Logistically, there's some real advantages for us having this Midwest production. So as we said, we have sales in 25 different states. So this gives us kind of a production hub that's closer to, the heart of the country. So it cuts down on some shipping costs. It cuts down on, reaction time and logistics. We used to get calls from people on the other coast, and they're like, how soon can you get stuff out here? We want to apply it this week. And I'm like, I can only make the trucks go so fast. So I'm talking to you growers, give these guys some lead time, but now we have an ability to be much more responsive.
Yeah.
And and have a good inventory of product there. And we are going to be producing almost all of our products in our product line actually out at the Ark Biome facility. So we have our Metagrow 5X Plus product, which is our concentrate, and that's the one that we use probably the most in the Midwest. So one of the things that we learned early on, and Elevate helped us learn this, is, we had our standard kind of foundation product is Metagrow ST. So it's got our most diverse population. So we went to the growers and we said, well, our standard application for this kind of crop is 2 gallons per acre. And didn't realize at first that we were getting pushback, that quantity of material was actually going to cause some logistical problems and a requirement to recalibrate applicators and all sorts of things. And so once I got better educated about what the resistance was, I said, well, how about if we come up with a more concentrated product, so we have the same number of microbes and species and diversity and function in a quart that we would have in or half gallon as we would have in 2 gallons. And the response was a complete change of attitude. It's like, oh, well, that's not a problem at all. Just throw that in the tank, and it's, one of the advantages we have is we produce a shelf-stable product. So the microbes are in stasis and they can mix with synthetic fertilizers. So, we do a lot of tank mixing and applications and things. So we discovered, thanks to the feedback from Elevate Ag and their customers, it's like, nope, the way to make this work, the way to integrate this into their production logistics is to have a more concentrated product. So we're going to do the 5X Plus there, which is a great product for the Midwest. We also will be producing our Metagrow C, which is a set of biology that's been epigenetically activated to have a metabolism to consume chitin. So there's very specific objectives that we're accomplishing with that product. We have another product called Metagrow G, which is very similar in strategy to the Metagrow C, but instead of a chitin-based metabolism, it's a glucan-based metabolism. Again, for some very specific sets of objectives. We also have our Metagrow Decomposer. So that's our crop residue decomposition product. So that's currently being shipped and applied all over the place in our post-harvest follow-ups. It's a great product. Would really recommend maybe another discussion about that. There's such a long list of benefits to that product. And then the other biological that we'll be producing there with Ark Biome in Nebraska with you is our Metagrow F product, which is a fungal dominant product. It still has a good bacterial and other biology balance, but it's a set of fungi that comes from a completely different trophic level of our other products, which are also fungally balanced, but it does a great job of bringing in and restoring the fungal population in the soil. And the reason why I specifically call that out for the Midwest is And again, this is the advantage of having the relationships and the people on the ground. So we started working with growers who'd been involved in regenerative agriculture for 20 years. So many of Keith's customers have been growing cover crops for that long, or and doing no-till or minimum till for that long. So people really doing the right things for a long time. And we started to look at those soils and realized that they had been very successful, that they were seeing a lot of benefits of restoring their biology. But every time that we looked at it, it tended to be still very bacterial dominant with very little fungal component. The fungi actually, they do things differently than the bacteria. They're better at some jobs than the bacteria. So especially when you're talking endophytic fungi, those are the ones that actually kind of their core or their kernel is actually inside the root, and their hyphae act like a extension to the root system as a root hair. Um, if you don't have that fungal component, you are really missing out on a bunch of the potential benefit of restoring your biology. So you've got this great foundation because you've been doing all these good things for this long. Metagrow F just allows you to climb that next step on the ladder of restoring that and capturing some of these other functions. And one of the things, and this is common all over the country, but um, fungi are really good at, they're the best at solubilizing and translocating phosphorus. So one thing that has gotten actually a lot of people involved in our crop programs, especially in the Midwest, but also out here, is growers frustrated with their phosphorus programs, where they would look at their soil test and they'd see, they do a total extraction and see they've got 40 years worth of phosphorus in the soil. And then every year they pull their plant tissues or do their sap analysis, and every year their crop is deficient in
To
phosphorus.
add phosphorus, yeah.
Yeah, and super frustrating, right? And they talk to their PCA, and the PCA says, well, let's put on more phosphorus. It's like, I've already got 20, 40 years worth of material out there. It's like putting more on is not going to change that. So anytime when we look at a soil, the soil has the nutrient potential or the nutrient sources, but the plant nutrient status is deficient. The answer to that problem is there's biology lacking to mineralize and deliver those nutrients. So that's where we really started to plug that hole, and we can see it, every time when we put our biology in, we start measuring, say, sap or tissues. We can see it move the needle on delivering better nutrient status to the plant. So the soil has nutrient potential, the plant has nutrient status, and we can translate that potential into healthy status. So we increase the nutrient efficiency of the plant, it captures more of that fertilizer and gets to those nutrient ratios that result in this really high photosynthetic efficiency and very, very strong, healthy tissues. So
Yeah.
yes,
And
I kind of went on that a little bit, but those are the biological products that we're going to produce at Ark Biome. I really liked the idea of, I think it was Armin who came up with the name Ark Biome, and I really liked it because immediately it kind of conjured for me the idea of two of everything. And that's kind of our approach with diversity, is that everything needs to be represented.
yeah, no, I like that too. It's a great name, has lots of meaning there. I want to go back and talk about just a couple of the products in particular. So the Metagrow F. So for any of you listening that have bought green cover seed, any of our cover crop seed in the last several years, we are putting Metagrow F right on the seed. On your invoice, you may see it as elevated fungi. That's kind of the trade name through Elevate Ag, but it's just straight Metagrow F. And so you are getting that fungally rich, fungally dominant compost extract, if you will, or biological product right on the seed. So, that's what we're doing. And David, I've got to tell you, just this week, I've had at least 3 or 4 customers that I've been working with on, seed orders, and they have specifically mentioned, yeah, we've planted your seed and we've planted other people's seed, and your stuff just germinates faster, it grows better. And part of that, I think, is, we're growing our seed in more regenerative environments. But I think part of that, too, is that it all is getting, that biological treatment of the Metagrow F or the elevated fungi. And I think that's just getting it off to a better start, a faster start, a quicker start. And, we're bringing the band all together, when we're putting that on, so that we not only have the seed, the biology that's on board and in the seed from growing, but then we're boosting that and supplementing that with your products as well.
Yeah, well, I love always hearing that feedback. Kind of harvest time is one of my favorite times of the year because I do get those calls and people sharing what their experiences have been, and
Yeah.
sometimes it leads to some great insights. And I think that seed inoculant it's a very powerful um, multiplier effect. So I think in terms of bang for your buck, it may be one of your best possible opportunities because you really don't use a tremendous amount of product,
No.
but you're putting the microbes right exactly where you need them. And also they get to participate and support the plant from the very beginning. So, there's a lot of things that happen very quickly in a crop that determine its ultimate yield. So I always think of it as inside that seed, there's an inherent genetic potential for what it's capable of. And any given moment through its entire growing cycle, anytime it doesn't have exactly what it needs, we're really eroding that potential or we're losing some of that potential. So, I always kind of cringe a little bit when people talk about making yield because that's already defined, that's baked in. So our job as growers is to screw that up as little as possible.
To not lose yield.
Yes, to just not lose it. So getting the biology going right at the beginning is critical because, as we mentioned, the plants and the biology co-evolved. So those relationships are really intricate. So, and I'll just even kind of just give a quick overview of some of the things that the microbes do that participate in that seed germination and stand establishment process. So there's microbes that actually help and soften the seed coat. So when moisture first hits that seed, the seed actually starts to put out exudates. So we talked about root exudates. There's also seed exudates. Those exudates are an invitation from the seed to the microbes to come colonize me. And it's also saying, I'm alive and come do your support functions. Because if it was a dead seed, it wouldn't have exudates and the microbes would actually have a saprophytic metabolism. They'd start digesting it because it's just residue, right? But when it puts out that exudate, says, nope, I'm alive, come help, colonize me, I'll reward you, I'll feed you. So the microbes soften that seed coat and help that moisture get penetrating, right? So that's part of speeding the, the activation of that seed. There's microbes that produce amylase enzyme, which is actually taking part of that endosperm and converting it from starches into sugars. So that's part of starting the engine of that seed, unlocking that energy potential into active energy in the seed. Then when you do things like cell initiation, well, that's indoleacetic acid. So that's plant growth regulator, which the seed produces, but the microbes also produce and support. And then it goes into cell division. That's different sets of hormones to trigger and also to moderate. And then there's cell differentiation and then cell elongation. So cell elongation can be things like gibberellic acid. Gibberellic acid is, of course, a plant growth regulator, and it's also something that the microbes produce. So that cell elongation is super important to stand establishment because the better that cell elongation is, the stronger that cotyledon and stem can break through a crust in the soil. It's also pushing the roots harder. So now you get an expansion of the root system. So the expansion and branching of the root system of the seedling is driven by things like auxins and cytokinins. also plant growth regulators that the microbes produce. So when you talk about getting a really good, germination and stand establishment, you get a stronger germination, a stronger emergence, a bigger, more robust root system. You get and faster and more uniform emergence. Those all equate to much more vigorous stand establishment. So, uh, and then so many important things are happening very, very quickly with that seed in the first couple true leaves. It's really still established. It's still building the chlorophyll. So when you see a first emergent little seedling, it tends to be a little chlorotic looking, and it doesn't really truly green up until third or fourth true leaf. Well, the faster you can build that chlorophyll, the faster you build the bricks in the sap of the plant, and the higher the defense mechanisms of the plant. So with the biology actively delivering the nutrients to the plant, so all those photosynthetic related nutrients, so magnesium, manganese, copper, iron, zinc, those are all cytophore functions that the microbes are doing to chelate and deliver those cations to the plant. You get that greening up faster, and so you get a healthier plant that has is faster growing. And so many plants decide quite a bit about what their potential yield is very, very early on, like by fourth true leaf, the corn plant's deciding whether it's going to have one ear or two.
Yep.
That's real fast. So the better we can get it off to the start, the less of that potential yield that we actually end up losing.
So super complicated processes. Thank God we don't have to manage each of those as humans, because there's no way we would ever get the timing right or the rates right or the amounts right. So that's why this natural system, if we set it up right, we have the biology there to help regulate it. Set up the system and then get out of the way, right?
Actually, get out of the way is a good thing that we always say. Yes, like make sure set the table, make sure that everything is there in available in abundance. But otherwise, get out of the way, because so many of the production problems that we see are actually self-inflicted. That we Oh, a good example would be, and we do a lot of things for practical and pragmatic reasons in agriculture, just for logistics. So, a grower might put on a whole season's worth, all of their phosphorus at planting. It's like, well, that was very efficient to your application, but very inefficient to the plant and to the biology, because the plant won't let, say, mycorrhizae colonize it if there's too much phosphorus available, because part of the reward to the plant for letting the mycorrhizae colonize is the mycorrhizae will deliver phosphorus. It does a great job of that. But if we put a high environment of ionic phosphorus around the plant, that doesn't occur. So, here we're doing something that kind of thwarts the process. So we need to make sure that those things are available as building blocks for the microbes to deliver, but we need to, get the table set and then get out of the way.
Yeah, self-inflicted wounds. Yeah, that is a common occurrence, and we just need to try to avoid those. So we're excited about being able to use the MetaGrow app for the elevated fungi on all of our seed. And you mentioned that it's a good bang for the buck. I like to say it's a good bang for less than a buck, because really that product. No, honestly, when we put that on cover crop seed, it's generally less than $1 an acre to add that. And so it's just a no-brainer. And so that just kind of comes as a standard part of any of our mixes, is gonna get, that type of a product. The other product, though, David, that I want to talk about a little bit, because it's very timely right now. You mentioned it earlier, and that's going to be the Decomposer. And that's because that typically is a product that is going to go on post harvest, and it's to really prepare the soil and the microbial population for next year's crop. So, talk a little bit about that Decomposer product and what that does.
Sure. Actually, I would like to backtrack just for a second because you mentioned something that I wanted to touch on.
Okay.
That feedback you got from your grower about the great germination and stand establishment that he got out of your seeds. Sure, we can take some credit for the biology we put on there as the seed treatment. The other part, let's not forget though, you grow your seed crops using biology as well. Some of that biology actually ends up inside the seed, and that's a really important set of biology. So, as much as we're adding biology from the outside, if the way you grow your crops, you've actually got that endogenous population inside the seed. So, what you're doing is you're creating a seed that has not only greater fitness and will result in that better germination and stand establishment, but it's also conferring additional source of diversity into every field that you put it on. So again, just another elegant way of how nature works, but also didn't want to miss the opportunity to give you credit for what you're doing in your growing process and making a healthier seed that not only germinates better, but it's also bringing beneficial biology to it, even without the seed coat.
Yeah.
But obviously, those are
Yeah.
complementary things.
No, thank you.
Okay,
Appreciate
so
that. Yeah.
sure, yeah, I mean, I think it's important, and nobody ever talks about it. So just want to put that out there. Okay, so Decomposer. Yeah, so it's a great bang for your buck opportunity. It takes very little material usually. So we've got our MetaGrow Decomposer product. Um, we typically, it depends on the type of product of crop residue. So if it's a light residue and it has a pretty good nitrogen to carbon ratio, then it really only takes about a gallon per acre of that. So something like soybean residue. So that's a pretty friendly residue. Doesn't take a lot of biology to really get that going quickly. If you got something tougher like corn or straw, anything that's like a straw color, and corn are going to be like 50 carbon to every nitrogen. And remember, I said that golden ratio is that 15 to 20 carbons
Yeah.
per nitrogen. So uh, those things are to our advantage if we use them correctly. So remember, I said there's a lot of nitrogen fixing microbes that will decide not to because in our native soil, in the soil that we have in our production soils, we have low carbon and high nitrogen typically. So oftentimes those guys that could fix nitrogen won't. But within the context of breaking down that crop residue that has a high carbon to nitrogen ratio, ooh, that's our best opportunity all year long to fix nitrogen and get free fertilizer. I was just doing an analysis of a field trial from the previous year, and I think we ended up with 96 pounds of nitrogen out of that. And I think it was about the same for phosphorus as well. So that was the pre-treatment versus the spring condition, but also that was net above the untreated. So the untreated did realize some gains, but that's what I just quoted was the amount of gain above the control.
So,
So
but before you go on, I want to go back and make sure I understand this. So
yeah,
you're saying that when you apply these products on a high carbon residue, that the biology is actually it's not just releasing the nitrogen that's in the residue, it's actually converting atmospheric nitrogen to plant available nitrogen without even having a growing plant. We're talking about dead residue, but we're still producing nitrogen. Is that what you're telling me?
yep, capturing it because they need it for their own purposes. They're also capturing other nutrients as well. So if you don't have biology and you have crop residue just kind of sitting on the soil, it does eventually disappear, but usually those are typically kind of oxidative processes. So you're volatilizing carbon in the form of carbon dioxide and carbon monoxide. You're volatilizing sulfur in the form of skatols and things like that. And you're volatilizing nitrogen in the form of ammonium. So you're losing all of that nutrient potential to volatilization when you don't have biology doing the active decomposition. Uh, and so instead, if we get the biology doing its job, it captures all of those nutrients. It incorporates them into their bodies. As those microbes die, of course, they take the carbon and that starts to form the humus in your soil. So that's raising your soil organic matter. That's raising your cation exchange capacity. So the ability to store more nutrients, but yet in a plant available form. And they're also, of course, have the sulfur there. And so those things are now locked up in your soil. You're not going to leach them out. You're not going to have them go off and run off. They're not going to volatilize. They're right there, right where the plant needs it for the next season in the form that it needs. So it does just a tremendous amount of stuff. And of course, in addition to the nutrient capture, we're also physically conditioning the soil in quite a number of different ways. So of course, chunks of crop residue can foul planters the following season or screw up a seed's soil contact, if it's rushing against, some unbroken down residue. So just by improving the planter operation and seed soil contact, we see improvements in germination and stand uniformity. So things that are important. Of course, as we break down those tissues as well, those tissues are a classic place for pests and diseases to overwinter. So if you don't break that residue, then you automatically have a higher risk of more pest and disease pressure being, present at the beginning of the season than if you'd broken that down and just denied them that overwintering habitat. So the other things I should mention is, so I talked about earlier that microbes have the ability to do a bunch of different jobs, right? And they'll choose which job they do based off of what the conditions are. So if you have a plant that's dead, it's not feeding or interacting with the biology. So it's senescent. The microbes actually switch their metabolism to do different enzymes and things. They're saprophytic at that point, so meaning that they're decomposers and their job is to break down the residue. So you build up this really big population that's very, very active. When that next crop gets planted, and again that seed puts out that exudate that's inviting the microbes to colonize it, that's part of them going, oh, now we're going to switch our metabolism from being saprophytic and break down processes. Now we're back to our metabolism where we're doing beneficial things for that growing plant. So you have this really active biology that's ready to step in and serve the plant.
That's really cool. And to think about producing nitrogen without having a growing plant, just because it's the biology that's doing it, so that shouldn't necessarily surprise us. But it just it's a different way of thinking, and so yeah, I would encourage folks to look at this Decomposer product. I think through Elevate Ag, we're selling that as Hyper Cycle. Or adding some food sources to it to really even boost that even more. So if you want to produce nitrogen in the off season and not even have a growing plant out there doing it, here's your opportunity. So you can contact Green Cover or Elevate Ag to learn more about that. Well, David, I think that I feel like there's a whole nother episode that we could talk about some of these other products, and I definitely want to invite you back on at a future podcast episode so we can talk about some of these other things because it's just fascinating to see how all of this works together. It's incredibly interesting to hear your perspectives on it because you've been in it for literally for 50 years and we just appreciate you sharing your knowledge with us. Maybe just in closing, for someone who has never tried any biological products, they've heard about it, maybe they're ready to kind of dip their toe into that water. What advice would you give them of just a good, safe place to get started using some biologicals?
Sure. Well, I guess I would emphasize that choose a product that has excellent diversity. So stay away from you can have success with products that are just a couple different microbe species, but it can be very hit and miss. It can be very frustrating. There can be all sorts of causes why those things might not be successful. Your chances of success are much, much greater if you choose a product to start with that has high diversity. The other thing I would say that is really, really important in getting started is to select an objective. Have something that you're trying to accomplish. Matter of fact, later on today, I'll be doing an hour-long presentation for a conference that the whole discussion is about how to select biological products. But just in short, select one that has diversity and have an objective. So if it's to save money on your fertilizer budget, that's a great, great objective. But right there, it tells you which product to select and then how to measure success.
I like that a lot. And yeah, maybe we'll have you back on for another episode because that sounds like a fascinating topic that, we all need to hear more about. So, again, David Olson, Sustainable Growing Solutions, thank you so much for sharing your time and your expertise. And folks, thank you for listening to this episode of the Green Cover Podcast. We hope that you have a great regenerative day. Thank you.
Thanks, everybody.